Hi, everybody. So I was supposed to talk about our formal lab report this week and totally forgot about it. So I'm going to just record a little video and get it posted to YouTube and to Canvas to hopefully get you started or answer any questions. And then, of course, as you're writing it or prepping to write it, if you think of anything, feel free to reach out. So I have everything pulled up on Canvas. I'm going to share my screen here. So what I have open right now is just the formal post-lab page for the formal report. And then I have all of these documents open in my many tabs up here. So we're just going to go through each of them and talk about how to write the report. Now, before we get started, if you had me last semester, the formal report last semester is the same as this semester in terms of formatting. Obviously, the experience is different, so the content will be different, but you are going to know most of what I'm going to say. All right, so with that out of the way, the very first document is called Formal Report Information. And so this is a list of the content that needs to be in your formal report. I'm going to zoom in a little here. So at the top here, it pretty much just told you what I said. There's two other important documents. One is the template, and that is going to be for formatting. So we'll look at that in a little bit. And then the other one is the rubric, and the rubric contains both. It contains content information and formatting information. So that's a really good checklist that you can use as you're going through everything. It doesn't have all the details, but then you can turn to this document for the content details and then the template for the format details. Okay, the few bullet points up here at the top are just some basic formatting information. Same things we've been doing, well, except for one exception, but past tense, third person, put spaces between numbers and units. And the very top one up here is the new stuff. So within the template, it has columns, it has specific fonts and sizes. So again, we'll get there in a couple tabs. All right, at the top of your report, it should be the title, your name, and if you worked with a partner, their name as well, and the address. So we do this report so that it looks like an official science journal article. And that means that you need to say where you did the science, where you did the research. So you're not going to put your home address, you're just going to put the school address. And then if you did have a partner for this, you're going to put an asterisk next to your name so that it shows that you were the main author of this report. All right, next section is the abstract, pretty much the same as what we've been doing. You're going to have the purpose of the lab, the procedure, the results, which will include your percent yield and any information about the purity, and then your conclusion. The rest of the sections are the main part of the report. The titles are here in bold, and on your report, you should also have them bolded. You can almost think of each part of the abstract becomes its own section. So the purpose turns into the introduction, the procedure turns into the experimental, the results turn into the discussion, the conclusion turns into the, I'm sorry, I think I said that wrong. The results turn into the results, the conclusion turns into the discussion, and then the conclusion itself is just a very quick 2-sentence wrap up. So within the introduction, again, you're talking about the purpose. It does need to include the actual reaction and mechanism for your specific molecule. So remember, we had a couple different aldehydes to choose from. And then the other important thing is that you need to connect it to the outside world. So this could be about one of the molecules in particular. It could be about the reaction itself. We are doing the aldol condensation reaction. So it could be something historical about it. It could be a way it's being used currently in research. Really, we just want to make sure that we're connecting it to something outside of our class. The experimental is the procedure. So it should be enough information that somebody could redo the experiment if they only had your paper. And you should have real experimental values in there. So if the lab said to use 1 gram, but you actually used 0.975 grams, it should say 0.975 grams in your report. And then don't forget to include any hazards and where you disposed of the waste. Okay, for the results section, you are presenting your your results, meaning you're going to tell me how much the product weighed. You're not going to tell me how much the watch glass weighed when it was empty and then when it was full. We don't need that level of detail. You should have your data organized in tables or at least bullet points. And for this lab, the information is going to include the mass of your product, the percent yield, the melting point, and a table of your IR data, as well as the calculations to show how you got theoretical yield and percent yield, and then your IR itself. And so your IR can be embedded in as an image, or you could attach it to the end, either way. The discussion section. So the results are literally just the data. The discussion is now talking about the data. So you want to compare it to literature values. So specifically the melting point and the IR. Were they close? Did you see the peaks you should have? And then comparing to expected results, that would be your theoretical yield, percent yield discussion. Do you have any impurities? Is there any unreacted starting material? How do you know you made the final product? So this is kind of just explaining those results essentially, mostly from the IR. This is getting into one of, or two of the questions from the textbook. How did you, or I'm sorry, was the product that you made cis or trans? And then how do you know? And then question number 3 gets into whether or not you could tell the difference within the IR. So how do you know that you made the trans based off of the IR peaks, or what would tell you that it was cis within the IR? And then the last is just kind of a wrap up of how was your data? So do you think that your data was decent? Or do you know that something went wrong and you know that your data is probably skewed? And to go along with that, were there any errors and how could it be improved next time? The conclusion is literally 2 sentences. So what was the goal and did you reach the goal? So the goal of this experiment was to produce acetaminophen. This goal was reached. Acetaminophen was produced in a 70% yield and it was pure based off of its melting point, color, and IR. So you don't need any details because if somebody wants the details, they can go back up into a higher section to read them. The last section are your references. So you need to have 4 references. Your Klein book and your Pavia book both count. So you can use your Klein textbook to reference the mechanism and the reaction. You can use your Pavia book to reference the procedure because obviously you didn't come up with it yourself. For your other 2, the most common way to do it is you're going to need a reference for your hazards because again, you didn't make them up, you found them online. And then the other one is when you have to connect it to something in the real world. That's definitely going to be a reference. So there's 4 easy ways to get your references. If you have more than 4, completely fine, but 4 is the minimum. To reference them, we're going to use ACS. So I know in a lot of other classes, you've probably used APA, maybe MLA. In chemistry, we use American Chemical Society formatting. So I will talk about that. I have a tab for it. And then you also need to do in-text citations. And again, I have this link opened up on a later tab where we're going to look at references. Down here, it's giving you a little bit more information. For the reactions and mechanisms, you need to use a chemical drawing software. I do have some linked on Canvas. I'll show you where to find those. And then for figures and tables, they need to have a title and a heading. So figure 1, substitution mechanism, table 1, IR results. The figures get labeled underneath. So picture and then label or title, and then tables get labeled above. So table 1 and then the table. Not a big deal, but that's the official rule. Okay, so I think we've gone over everything on here. The next document is the actual rubric. I'm gonna skip him for a second. We'll come back to him after we look at the template. So let's see, I'm gonna get rid of that link. So I have the template on here twice. I'm gonna go back here to show you. So I have the template right here. This is a Word document, but then I also have the link to the American Chemical website in case you need a Mac version. So here's what the template looks like. The first part is just delete it. It's just giving you some information. And then here's the template itself. So a spot for your title, a spot for your author's name and address, and then a spot for your abstract. And then the rest of it is for your report. Now, the text that's in here is giving very detailed information about like the size of your figures and what the caption should be, because this is what American Chemical Society authors are using. So most of this is more information than we need. But the font, the columns, the fact that it's justified, so meaning you have this nice flush line right here, that's what we're using it for. Looking to see if it does have a little template for a table, which you can use. And then I do have some examples of other ones, so I'll show you those as well. But this is the template. The template might be the harder part of this report. The content isn't too difficult. It's obviously a little bit more than a regular lab report, but the formatting can be the tricky part. So don't save that till the end. My other suggestion is don't type it in like Google Docs and try and copy and paste it over, because the formatting won't stick unless you very specifically know how to do that. I would suggest downloading this and typing directly into the template. Okay, we're going to get rid of him. And then this is the American Chemical Society website. So it has the template on here for Windows and for Mac, Windows for Mac. So they are on there. And remember, you do get access to free Microsoft Office through school. So if you think you don't have Word on your computer or your laptop, your tablet, you do. You just have to access it through the school website and then you get it for free. Okay, let's see. Let's get rid of this guy. So the next couple documents or websites are how to do the references. So this is linked on Canvas. It is right here, the ACS reference guide. And it tells you how to reference any type of resource. So we're starting with books. So you'll probably need that one for the Klein and the Pavia textbooks. And then I'm going to scroll to the bottom because the other ones that you will probably use, we do have a safety data sheet one. So you might use that for your references for the hazards. And then the other one is just literally a website. So you would put who made the website. Of course, we want to use reputable websites. So this will probably be a school or a government organization, and then the website itself, and then the day that you accessed it to get that information. Sometimes this is easy to find, meaning the very first part here, and sometimes it's a little bit more difficult. But we do want to make sure that we're using reputable websites. So even if you're going to like Wikipedia to find something, scroll down to the bottom and see where that information came from, because all of the information on that website is sourced. Okay, so there's your references. Get rid of this. This is the link that was on the information page on how to do in-text citations. So again, this is ACS formatting. There's 3 ways to do it. They're all correct. You just have to pick one and be consistent and stick to it. So the first one is superscript numbers. So at the end of your sentence, you would have the number of the reference and it would be after the period as a superscript. If you're using this at the end of your document, all of your resources are just going to be listed 1, 2, 3, 4 in order of however they showed up in your paper. So whatever you're using in the introduction would be your first reference. The second one is putting the reference number in parentheses at the end of the sentence. It's in italics. This is pretty much the same as the first one, just the number formatting is a little bit different. And then the last one is at the end of the sentence, you would put the author name and the year of publication in parentheses. This is the most common when you're looking at a journal article, but it's the least common for something like what we are doing because we have a lot of digital resources. We're not referencing other journal articles. So it's not as easy for us to do this formatting because we're not going to want to put Michigan State University or, whichever school's website we were using. It's just too long. So I would suggest one of the number ones, but again, pick one and stick to it. Okay, I'm going to get rid of this link. All right, so the last 3 documents that I have down here are some examples. The first one is actually an ACS journal article. It is doing some COVID research. So we have the title, we have all of the author names, and notice all of the little symbols next to their name because it's referencing all of their different locations. But the very last author, we have a couple stars because again, that means that they were the main authors for this report. We have their abstract, and then it gets into an introduction. We have the results. Here's one of their tables with the title above it. Oh, and then for tables or figures, it can go all the way across the page like this one, or it can be within the column like this one, whichever one makes more sense for your size. And then when you do have, let's see, let's go back to this one. When you have a figure like this, so these are graphs, but it would work for reactions as well. You would put the figure number and caption below it. And then if we scroll down, we're into their discussion section now. And then this was, since it was COVID research, we get some lovely pictures of lungs. At the very end, we have their reference section, and so they are using the number version. A lot of professional articles will also have an acknowledgement section. A lot of times this is to thank either their like research advisors, their postdocs, maybe the person in charge of the grant. They're often called the PI, or even just to thank their funding resources. So just when you see that, that's what that means. And then, so this one has 51 resources, very many. It's also 16 pages. That is not how long yours is going to be. Yours will probably be 2 to 3 pages. There's not a page minimum or maximum, but that's just kind of the norm. All right, I'm gonna get rid of that. So then I do have a couple student examples. These are not the same reaction or experiment that you are doing, but it'll kind of give you an idea of what other students have done. Some of them are from when I taught in Fresno, just because they were good examples that I held on to. And some of them are more new. Every semester I do change the requirements slightly. I just kind of edit it as I go along. So if you see something in here that I didn't ask of you, it's because the requirements have changed since this was posted. But we have this student's reaction, we have their mechanism, we have their tables of data, we have their references. And then if we look at the other one posted, so this one's more new. This one is from this school. I think it's maybe a year old, maybe a little bit older than that. But again, we have that first reaction, we have a mechanism, we have their tables of data, and so on. And then we have the references. They ended up having 6 references. Okay, we have 2 more things to talk about. The rubric. So this is the rubric. It looks really detailed, but that's for a good reason. One, it helps you make sure that you know exactly what's required in each section and how many points it's worth. And 2, it helps me grade it. So it makes me more consistent when I'm grading. And it just makes it very clear as to what was expected and how much it's worth. So in each section, there is this last section, the grammar, spelling, accuracy, and quality. So this is just to kind of pick up little errors that weren't included in what the main content was. This is not going to have anything new on it. This is going to have the information from the rubric, or excuse me, from the template and from that information page, all condensed into this one. So even down here with the minimum of 4 sources, with those in-text citations, using ACS style, and then making sure you have your IR attached. Okay, last thing. So I'm back onto our Canvas page. I'm going to go back to our modules. And in the very first section, the class information, we have a module just labeled useful links. That's where I'm going to head. And at the bottom of this, I have 4 links down here to free chemistry drawing software. These are ways to draw out the reactions and the mechanisms so that they look nice and professional. I use ChemSketch. ChemSketch is what I use to make our sorry, the one I used to make our exams. And the other ones, I have some information on here about them. Specifically, this one's good for Mac users. Some of them you can't easily copy and paste the drawings that you make, but you can always do a screenshot and then crop it as you need to. So just kind of keep that in mind. You might not be able to save what's on there. You might have to draw it out in one go and then screenshot it over. Okay, I think that is everything. I hope that that was helpful. Sorry the video ended up being a little bit long, but I wanted to make sure we got everything in there. So as you're writing it, as you're prepping to write it, if you have any questions, feel free to reach out and I will help you out. I think that's everything though. Have a great weekend.